Right triangle trigonometry. Let's consider the following right triangles with theta as one of its acute angles, meaning the measure of this angle is less than 90. This little square box here tells you it's a right triangle, meaning the measure of this angle is 90. The third angle is also an acute angle, and also the sum of the two acute angles in a right triangle is always going to sum up to 90 degrees. Now, the sides, the three sides that we have here, the side that's opposite of the right angle is called the hypotenuse, and that's the longest side of the triangle. Well, the opposite and adjacent sides are relative to the angle you're focusing on. So based on this acute angle that we have here, the side opposite of that is called the opposite side. And the one next to it is the adjacent side. Now, what would happen if my theta was right up here? Well, if theta is up here, your opposite would be the side opposite of that angle. This would be called opposite, and that would be called adjacent. They will swap. So make sure you're labeling the sides relative to the angle that you're looking from. So if this is the theta, opposite of that theta should be your opposite side. If it's over here, then the opposite side would be opposite of that angle. Okay, so the trigonometric ratio that we can form based on that triangle that we saw, we have 6 of them. The first one that we're going to look at is the sine theta. Well, the sine theta is defined by the side opposite divided by the hypotenuse. Cosine of the angle, or cosine of theta, is equal to the adjacent side divided by the hypotenuse side. And then we have a third one, which is the tangent of theta, and that is the side opposite divided by the side adjacent. The reciprocal of those are the other three. CSC, which stands for cosecant of theta. Cosecant of theta is basically the reciprocal of sine. If sine is opposite over hypotenuse, cosecant would be the hypotenuse over opposite. And then secant would be hypotenuse over adjacent. Of course, that's the reciprocal of cosine. And tangent, or the cotangent, would be the adjacent over the opposite. So the symbols we use of this ratio are abbreviation basically for the full names: sine, cosine, tangent, cosecant, secant, and cotangent. Remember, the last three here are just the reciprocal of this. If sine is, for example, 2 over 3, the reciprocal of sine, which is cosecant, would be 3 over 2. Let's look at an example here. Suppose we have the following triangle here. What would be the 6 trig functions based on the right triangle that we have? Well, the first thing that I would do in this case is that I would label the sides of the triangle. Opposite of theta, which is this side length, that's called the opposite side. The longest side is always going to be across the right angle, and the name for that is the hypotenuse. And of course, the side length right next to the angle is the adjacent side. Now, once you label the right triangle, then go based on the definition of sine, cosine, tangent. So let's say we want to find the sine theta. The sine theta is defined as the side opposite divided by the side hypotenuse. Well, opposite of theta is 3, hypotenuse is 5, so basically you just divide those two numbers. Cosine of theta, which is the adjacent side, over the hypotenuse. Adjacent is 4, hypotenuse is 5, so that would be 4/5. Tangent of theta is the side opposite over adjacent, and as you can see here is 3/4. Opposite over adjacent. Now the reciprocals, cosecant is the reciprocal of sine. So if sine is 3 over 5, cosecant would be 5 over 3. And the same thing goes with cosine and secant. Tangent and cotangent are reciprocal of one another. Example 2, cosine of theta is equal to 3/4. Find the other 5 trigonometric ratio of theta. Well, in order to find the other 5 trigonometric ratios, we need to make a right triangle. So the first thing I would do is create a right triangle and of course label the sides of the triangle. As we said before, opposite of theta is your opposite side. This would be the hypotenuse, which is right across the right angle. And of course, the third side would be your adjacent side. What we're given is that the cosine of theta is equal to 3/4. Remember, the definition of cosine is the side adjacent over the side which is the hypotenuse. So in this case, my adjacent side length would be 3, and then the hypotenuse would be 4. Now, because we're dealing with a right triangle, if you know the two sides, the third side could be found by applying the Pythagorean theorem, which states that a squared plus b squared is equal to c squared, where a and b are basically the leg of the triangle. You can label them however you want, but your a and your b has to be one of those two sides here. The c is always your hypotenuse. That's the longest side. So I'm going to decide to make this is going to be my b, and that's going to be my a. Of course, this would be your c. So if I substitute the values, I get the following here. Square them. Now, we need to solve for a, which is the opposite side. We're going to subtract 9 first on both sides. And then in order to solve here for a, we're going to take the square root on both sides. And because the measure of the length is always positive, a is going to be the square root of 7. That means the measure of that opposite side is root 7. Now we can find our sine theta. The sine theta, which is defined as the opposite over the hypotenuse, is going to be equal to root 7 over 4. Tangent is defined as the side opposite over the adjacent, so that would be root 7 over 3. Secant, which is the reciprocal of cosine, is going to be the flip-flop of your cosine value. And of course, cosecant is the reciprocal of sine, which would be the flip-flop of this number right here. So 4 over root 7. And in math, we don't like to have a radical in the denominator. So what we do is we multiply by the square root of 7, both sides, top and bottom. Over here, you get 4 times the square root of 7. But root 7 times root 7 is the square root of 49, which simplifies into 7. So as long as you have the same number inside the radical, that's just going to simplify into that number as when you're multiplying. And then the same thing with cotangent. Cotangent would be the reciprocal of this, so that would be 3 over root 7. Multiply top and bottom by the square root of 7. 3 times root 7 is what you get here. And then down here, square root of 7 times the square root of 7 is the same thing as the square root of 49, which simplifies into the number 7. So you get 3 root 7 over 7. So those would be the 6 trig functions. Example 3 is, what if you're given one angle and one side? Well, in this case, what we're going to do is we're going to apply one of those 6 trig functions. And mainly the 3 functions, sine, cosine, and tangent, is what we're going to use. Well, we know the angle, we know the hypotenuse. What we don't know is the side opposite and the side adjacent. So in order to find a and b, we have to use one of the trig functions. Notice here, you cannot apply the Pythagorean theorem because we don't know the measure of two sides. We only know the measure of the hypotenuse. So how do we solve the side length a? Well, since a is opposite of the angle, and the hypotenuse is the known, use the definition of sine. And that's because sine deals with opposite and hypotenuse. The definition of sine is the side opposite over the side hypotenuse. And that's what we want to find is our A. So how do we start this? Well, the sine of the angle, which in this case is 30, sine of 30 is going to be equal to opposite, which is A, over the hypotenuse, which is 12. And then basically just solve for A here. Multiply both sides by 12. The 12s cancel on this side. So you have A is equal to 12 times the sine of 30. And make sure your calculator is in degrees. And if you simplify this, you get A equals 6. So that means the side opposite measures 6 units. How do we find the side length B? Well, in order to find the side length B, which is the adjacent side, and what we know is the hypotenuse. Adjacent over hypotenuse, that's the cosine function. And then we basically use this to find side B. So the cosine of the angle, which would be the cosine of 30, equals adjacent over hypotenuse, which is B over 12. And solve for B, multiply both sides by 12. The 12s cancel. B is going to be equal to 12 times the cosine of 30, which is approximately equal to 10.39 units. All right, let's look at this example. We want to find the missing side length of each triangle. So first, we're going to focus on the bottom triangle. So what you notice here is that the measure of the two angles are the same, and therefore the side opposite of the angles should be equal. Since the measure opposite of this 45 is 15, the measure across that angle should be 15 as well. So we know automatically that P should be 15 units long. Now, when it comes to R, we have a right triangle and we know the two sides. Well, since we know the measure of the two sides, we can use the Pythagorean theorem to find the third side. Or we can apply the trig function. We're going to focus on one of the angles, one of the acute angles. Let's say we focus on the bottom acute angle here. Then I can form a trig ratio here. I can say the sine of 45 is equal to the side opposite over the hypotenuse, meaning the sine of 45 equals 15 over r in this case. And let's go ahead and solve for r. We can multiply both sides by r. R crosses out here. So you get r, the sine of 45 equals 15. Sine of 45, if you have the unit circle with you, that is equal to the square root of 2 over 2. That's the exact value of the sine 45. And how do we get that? Well, if you look at the unit circle here, 45 is right here. The sine of 45 is going to be this value right here. The sine value is always the second number in the parentheses. The cosine would be the first number. So the sine of 45 from the unit circle is root 2 over 2, and that's the exact value. If you use a calculator, you will end up with a 0.707, and we don't want to use those. We have to go based on the unit circle. So now from here to solve for r, we can just multiply both sides by 2 to eliminate this 2 from this side. So we have r times root 2 equals 30. Divide both sides by the square root of 2. Square root of 2 here cancels. So we get r equals 30 over root 2. Now, to get rid of this radical from the denominator, multiply top and bottom by the square root of 2. Once you do that, over here you get 30 times root 2, but then the bottom simplifies into the square root of 4, which is 2. 30 divided by 2 is 15, so you get 15 root 2 as your final answer. So the measure of r in this case would be 15 root 2. Now, let's focus on the other triangle, which would be this triangle right here. What we figured out is your r, this length here, is 15 root 2. How do we find the measure of t? Now, in order to find this t, the known side here is the adjacent of 30. What we're trying to find is the hypotenuse. Adjacent over hypotenuse is the cosine function. So we're going to say the cosine of 30 is equal to adjacent over hypotenuse. Now from here we can just use the unit circle. The cosine of 30, if you look at the unit circle, this is my 30 degree. The cosine of that would be the first number in the parentheses. So cosine of 30 is root 3 over 2. If you use a calculator, the cosine of 30 is 0.86 and so on, which is not the exact value. So the exact value, you can only find it using the unit circle here. So instead of cosine 30, we're going to replace this by root 3 over 2. So you get the following here. Now, to solve for t, well, since we have a fraction equals another fraction, let's cross multiply. T times root 3, you get t root 3 equals 2 times this would be 30 root 2. Divide both sides by root 3 to get t by itself. Now, to get rid of this radical, multiply top and bottom by the square root of 3, which simplifies into root 3 times root 3 is 9. The square root of 9 is 3. So the bottom becomes 3. Up top here, square root of 2 times the square root of 3 is the square root of 6 because 3 times 2 is 6. The 30 stays as 30. 30 divided by 3 is 10, so you get 10 root 6 for the side length of t. Now, t is equal to that. To find q, we're going to focus on this triangle, and depending on which side length you want to use, it's going to be a different trig function. So let's say I want to find this using the hypotenuse length. So that means what I'm trying to find is opposite of the angle. What I know is the hypotenuse. So opposite over hypotenuse, that's the definition of a sine function. So we can say the sine of 30 is equal to q over 10 root 6. Now, the sine of 30, we're going to look at the unit circle. 30 degrees right here. The sine value of 30 would be the second number in the parentheses, which in this case would be 1/2. So sine of 30 could be replaced by 1/2, so you get 1/2 equals q over 10 root 6. Now the next step from here would be to multiply both sides by 10 times the root 6. And of course that's to eliminate the 10 root 6 on the side here. What does that simplify to? Well, 10 root 6 times 1, that's 10 root 6 divided by 2. Well, 10 divided by 2 is 5, so you get 5 root 6. So q in this case is 5 root 6. So the exact values of each missing side length would be as following here. All right, difference between angle of elevation and depression. Angle of elevation is basically when you're looking upwards, the angle formed by this horizontal line and the line of sight is called the angle of elevation because you're looking upwards. As for depression, the angle that is formed by this horizontal line and the line of sight is called the angle of depression. Those two would be used on the next examples. Okay, this example, a giant redwood tree casts a shadow of 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7. So the shadow, which is right here, is 532 feet. The angle of elevation, which is this angle, is 25.7. What is the height? Well, since the angle is right here, the known side is adjacent of the angle. And what we're trying to find is opposite of the angle. So that means the side that we want is the opposite, and the known side is adjacent of the angle. So we use the definition of tangent. So we say the tangent of theta is equal to the opposite over the adjacent. Well, we know what theta is, the angle. So tangent of 25.7 is equal to opposite, which is h, over the adjacent, 532. To solve for h, multiply both sides by 532. 532 cancels here. H is going to be equal to 532 times the tangent of 25.7. Make sure your calculator is in degree mode. That simplifies into about 256 feet. So the giant redwood is about 256 feet. Okay, a water tower is located 325 feet from the building. So the distance from here to here is 325 feet. From a window in the building, an observer notes that the angle of elevation to the top of the tower is 39. So from here to here, the angle that is formed from this horizontal line to the line of sight is 39 degrees. And the angle of depression to the bottom of the tower is 25. So from the window here to the bottom of the tower makes a 25 degree. How tall is the tower? So that is the sum of the length A plus the length B. And how high is the window? Well, the height from here to the window is the same as the height from here to this line right here. So how do we solve this problem? Well, first, let's find how high the window is using the triangle right here, the bottom triangle. We know the distance from here to here is the same as the distance from here to here. So what we're trying to find is the side length A here. So what else do we know? Well, also we know this horizontal distance from the bottom of the tower to the building is 325, which means it's the same length from here to here. So what we're going to look at is this bottom triangle right here to solve for the side length of A. And since what we're trying to find is opposite of our angle and the known side length is the adjacent side, we're going to use the definition of tangent. So tangent of 25 is going to be equal to the side length opposite over the side length of the adjacent side, which in this case becomes A over 325. To solve for A, we can multiply both sides by 325. Cross out the 325 from that end. A equals 325 times the tangent of 25. And again, make sure your calculator is in degree mode. If you use a calculator, that is approximately equal to 151.55 feet. So the length from the bottom of the building to where the person is a distance of 151.55 feet. Now, next we're going to use the top triangle to find the side length of B. Now, since what we're trying to find is opposite of the angle 39, and the known side is again adjacent of that angle, we're going to use again the tangent. But in this case, we're going to use the tangent of 39 equals opposite B over 325. Same process, multiply both sides by 325. 325 cancels. B is going to be equal to 325 times the tangent of 39 degrees, which is approximately equal to 263.18 feet. Now, the height of the tower, remember, the distance from the bottom of the tower to the top of the tower is the length of A plus the length of B. So that means 151.55 plus 263.18, which sums up to 414.73 feet. So we know that the height of the tower is 414.73 feet, and the height from the bottom to the window is 151.55 feet. All right, given the following information to the right here, what is the height of the building? And of course, the length of the flagpole, which is from distance from here to here. Well, first we're going to find the height of the building using the bottom triangle, because the height from here to here has an angle of 24 degrees. So how do we find that angle? Well, let's focus on the bottom triangle. What do we know? Well, the angle of elevation from the point on the ground to the top of the building is 24 degrees. The side adjacent to the degree is 500 feet. What we're trying to find is this height, which is opposite of the angle 24. So we're dealing with opposite and adjacent, and that is a trig function tangent, right? We can say the tangent of 24 is equal to h over 500, which is the opposite over the adjacent. Multiplying both sides by 500 eliminates the 500 here. You get h equals 500 times tangent of 24. Now, using a calculator, that simplifies into 222.61 feet. So that means the height of the building is approximately equal to 223 feet. Now let's find the total height, that is from the bottom of the building to the top of the flagpole. And for that, we're going to use this triangle right here. And what do we know about that triangle? Well, the angle to the top of the flagpole is 27 degrees. The adjacent side is 500 feet, and the distance from the bottom of the building to the top of the flagpole is what we call the K. So again, the unknown side is your K, which is opposite. The known side is adjacent. Opposite over adjacent, that's the tangent function. So tangent of 27 is going to be equal to K over 500. Multiply both sides by 500. You get K equals 500 times the tangent of 27. Using a calculator, that simplifies into 254.76. That means the height of the building plus the flagpole is approximately equal to 255 feet. Now, the question says, what is the length of the flagpole? Well, if we know the distance, the length of K and the length of H, we can subtract those two to get this distance from here to here, which is the length of the flagpole. And in this case, the length of the flagpole would be 255 minus 223, which is about 32 feet.